Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 2x plus 3 divided by square root of x square plus 4x plus 1. So what we have been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let us write down our y. Now that's my y. I see that my y is not in a very simple format whose antiderivative I know from first principles. But then when I take a closer look at y, I see that I have a quadratic expression inside the square root in the denominator, and then I have a linear expression in the numerator, right? So the way to go about solving these problems is, can I make a connect between the denominator and the numerator? My d by dx of the quadratic expression in the denominator in this particular case is d by dx of x squared plus 4x plus 1, right? Now what is that? That's a 2x plus 4. But then I have a 2x plus 3, right? So how do I bring about the connect between the two? So that's what we will look at in the next step. Before that, let me write down what is my d by dx. D by dx of x squared plus 4x plus 1, I apply the sum rule of differentiation. D by dx of x squared is 2x and d by dx of 4x is 4, right? And then my d by dx of 1 is a 0, right? So this is what we get, a 2x plus 4, right? Now I have a 2x plus 3 in the numerator. So unlike some of the previous videos where we had to work out the coefficients in order to try and express the numerator in terms of the derivative of the quadratic expression in the denominator, here I don't see that it is that complex because my 2x plus 3 can be straight away written as 2x plus 4 minus 1, right? And then I have my denominator as it is, right? So now I see that I can decompose this further, but while doing the decomposition, it's very important that I group them correctly. So I combine 2x plus 4 and then I treat the minus 1 separately, right? So let me highlight that in a different color. So now in the subsequent step, I will apply the sum rule of integration. And what do I get? So my part 1 will be 2x plus 4, the one which I've highlighted in green, the whole divided by square root of the given quadratic expression times dx. And then I come to the second part, minus of dx by square root of x square plus 4x plus 1 is my second part, right? So now we have two parts to solving y. So I'm going to call the first part as y1 and my second part is a y2, right? So the answer to this problem is a y1 minus y2. So let's pick up y1 first. So this is my y1 and I can solve this very quickly using a simple substitution because I know that my 2x plus 4 is nothing but d by dx of the quadratic expression below. So I have t equals x squared plus 4x plus 1, which means my dt equals 2x plus 4 times dx. And when I go back to my y1 and put back everything in terms of t, what do I get? My first part, which is the numerator, becomes a dt, and my second part, which is the denominator, becomes a square root of t, right? Now what I do is multiply and divide by a 2. The 2 in the numerator, I bring it out of the integral. And what happens now is I have an integral of dt by 2 root t. Now this is not too difficult because we know that d by dt of root t is 1 by 2 root t, right? So the answer to this is 2 times square root of t, and then I go ahead and replace my t to express my final answer in terms of x. And when I do that, what do I get? Y1 equals 2 times my square root of x square plus 4x plus 1, right? And then I have my constant c. So this is my y1, right? Now let's move to y2, and my y2 needs a little bit of work, but it's not very new to us. We have solved very many problems of this type. So I have integral of dx by square root of x square plus 4x plus 1, right? So plain quadratic in the denominator but sitting inside a square root. So the way we go about solving this is express the quadratic in the format x plus or minus a the whole square plus or minus b square, right? So this is not very difficult and allow me to do it on the same line. We've solved multiple problems of this type, and by this time, you must be quite familiar how I can reduce a quadratic expression to the type which I mentioned just now, right? So I have my x square, I write it as it is, right? And then my 4x, what I'm going to do is I'm going to write it as a 2 times 2x, right? And then my plus 1, I'm going to write it as a 4 minus 3. Why is it? Because if I write it as a 4 minus 3, I can combine my x square plus 2 times 2x plus 4 and rewrite this as x plus 2 the whole square, right? I'm referring to the expression which I highlighted in yellow. And then I have a 3 as well. Let me highlight that in, say, a different color, which is, say, green. I can rewrite that as root 3 the whole square, right? So this way we will be able to bring it to the format what we initially discussed, right? So let me write down my y2 in the new format. So that's my y2, integral of dx by square root of x plus 2 the whole square minus root 3 the whole square, right? So I go to the next line. The way to go about solving y2 is pretty much familiar to us. Step 1, I do t equals x plus 2, which means my dt equals dx, right? So this way I'll be able to reduce it to the form integral of dx by square root of x square minus a square in this particular case, except that in place of x you're going to have a t. So what happens to my dx, which is dt, and then I have a square root of my x plus 2 the whole square becomes a t square, right? And then I have a minus of square root of 3 the whole square. So from here on, we make a simple trigonometric substitution to solve the rest of the problem, and want to draw your attention to two trigonometric formulas which we use to solve problems of this type. So we have a secant squared theta minus tan squared theta equals 1, and similarly a sine squared theta plus cos squared theta equals 1, right? So I don't think my sine squared theta plus cos squared theta equals 1 is going to help me solve this problem. So what's going to help me solve this problem is the secant squared theta minus tan squared theta equals 1. So let me make the substitution t equals root 3 times secant theta. So what happens to my dt is nothing but a root 3 times secant theta tan theta d theta. So now what do? I go back to my y2 and try to express everything in terms of theta, and you will see that my y2 is a lot more simpler than how it looks right now, right? So let's go and make the necessary substitution. I have a dt in the numerator, so I'm going to replace it as root 3 times secant theta tan theta d theta. And in the denominator, I have a square root of t square minus root 3 the whole square, which is nothing but a root 3 square times secant square theta minus root 3 square. So I can pull out the root 3, and then I'll be left with a square root of secant square theta minus 1. And what is your secant square theta minus 1? It's nothing but your tan square theta, and you have your tan square theta inside the square root, which means that that becomes a tan theta, right? Now I notice that I have a tan theta in the numerator and a tan theta in the denominator, and I can also cancel out the root 3 out there, which means I'm left with integral of secant theta d theta, right? Now, this is not very complex, and if you folks are wondering how do I go about solving integral of secant theta d theta, please take a look at my description in this particular video, I'll be providing a link to solving for integral of secant x dx, right? And otherwise, I would suggest that you should remember this as an identity, right? Because this is going to help you solve many of the complex integral calculus problems, right? So the answer to this is log of secant theta plus tan theta. And then I have my constant c. Remember the mod inside your log, right? And here again, I cannot leave my answer like this. I'll have to put back everything in terms of x, right? So what's that substitution we made? We made two substitutions. The first substitution that we made was t equals x plus 2, right? So let me highlight that in yellow. And then the second substitution that we made was t equals root 3 times secant theta. So I start off with the most recent substitution, which is my root 3 secant theta equals t. So what happens is my first part within the log becomes a t by root 3, right? And then I come to my second part. What is my second part? I have a tan theta within the log expression. My tan theta is square root of secant squared theta minus 1, right? And what does that mean? It means that it is square root of t by root 3 the whole square minus 1. So I have t square by 3 minus 1, right? Now what do? I have it in terms of t, but then I'm expected to express everything in terms of x. So I go back to the first substitution, t equals x plus 2, right? So my y2 becomes log of my t by root 3 is nothing but an x plus 2 divided by root 3, right? And then I come to my second part, which becomes a square root of, I have a t square by 3, right? Now I'm going to represent it in a slightly different way, and it does not change the expression in any way. I have made root 3 common to the first part and the second part, which means that I have an expression of the type log a by b, where my b is a constant, right? So let me write it once again in a manner that will help you understand. Then I have a divide by root 3, right? Now my root 3 is a constant, right? And then I know that my log a by b is nothing but a log of a minus log of b, right? So I already have a constant c, and I can combine this constant c with the log of root 3, right? So what happens to my y2 is it becomes a log of x plus 2 plus this expression what I have x plus 2 the whole square minus 3, which is inside the square root, of course. And then I have a constant c minus log of root 3, right? So now the c minus log of root 3, I can combine this because that's also a constant. And what I'll do in the subsequent line is I will write it as another constant c1, right? So this is my y2. I hope you folks are with me. Now I go back to my y, right? Now that we have the answer for y2, let me highlight my answer for y1 and y2 in a particular color, say green. So I have my y2, I have my y1 as well, and my y1 is here. So let me highlight that in green as well. Now I go to my y, which I expressed as a y1 minus y2, right? So what's my y now? My y equals y1. Don't have to do anything, just copy paste as it is. We can take a look at the constants towards the end. 2 times square root of x squared plus 4x plus 1, and then I pick up my y2, and remember that we have a minus sign out here, and then I have my constant c, right? I mean, you have your constant c as a part of y1, and then you have a constant c1 as a part of y2, and you put both of them together, you're again going to get a constant, right? So it can always be expressed as C, or you can call it C1, C2, whatever you want to, right? So now I have this. Is there any further simplification I can do? I can do a little more to the final answer here, because this expression x plus 2 the whole square minus 3, what is it? It is nothing but x square plus 4x plus 1, right? You just do the expansion and see. You get x square plus 4x plus 4 for the x plus 2 the whole square, and that minus 3 you will get an x square plus 4x plus 1, right? There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.